Hello learners, this is Priyadarshi Shubhakant and I welcome all of you to my sessions on CNC milling machine. And as we have completed the sessions on datum setting as well as homing, from today onwards we'll be knowing the different types of program, how to write it and how to run that same program on CNC milling machine. So the first program for you on today is regarding the facing cycle. So let us start our today's session. So let us start with the facing program first, then after that we'll see how this program is run on a CNC machine. So first of all, I have calculated all the coordinates for this particular program, and the tool path in the blue color, you can see how my tool will move. I have used a end mill over here which is of dia 12, and the moment you can see in a zigzag manner it has moved from the start point to the end point, and accordingly to that one I have calculated its coordinate of different points and considered the center reference point of the job is at the center of the job. That means the datum setting I have done is at the center of the job. That means x0 and y0 is at the center. So let us start the program now. So first of all, starting with the program, as you can see, O0010 is the program name or the number I can say. Then G28, G91, Z0 is the homing for the Z axis. Then G54 is for the work offset which you are using, that is G54. G80 is your drill, G80 is your can cycle cancel, then G90 is your absolute mode of coordinate system, then G40 is your tool nose compensation or tool nose radius compensation, G40 is tool nose radius compensation cancel. Then moving on to the next line, G00 x minus 48 y40, that is my starting point, I will call it first. Then after that I will make the spindle on, that is M03 S700. Then I will go for a safety height, that means I have not called the tool towards the surface of the job. So now I will call it towards the surface of the job, but still I will keep 5 mm as safety. So it will be at the rapid movement, that's why it is G00 Z 5.0. Then M08 next it is there, that is coolant on. Then next has1 is equal to 0.2. has1 is a variable, it is used in the macro programming. This particular programming, the facing program, I have done in a macro programming method. So the variable I have used over here is has1. You can use has2, has3, has4, whatever it is there you can use, up to has33 you can use it. These are the local variables of a FANUC controller. So here I have taken has1, that is 0.2, that is my first initial depth. As you can see over here, n1, why I have written n1 I will be telling you later on. So G01 Z minus has1, that means has1 value is how much, that is 0.2. So the cutter will move towards that much, that is my incremental depth of cut, that is the first depth of cut. And at what feed rate it will go? It will go at 50 millimeter per minute. Then next, the other coordinate it will go, that is G01 x40 and y minus 40. You can see the starting point in the arrow mark I have mentioned. So from that it will move towards the second point. You can see the blue color line, it has moved to the second coordinate, that is x40 y minus 40 at a feed rate of 560 millimeter per minute. Similar way to the third coordinate, x40 y minus 30, and similarly you can see x minus 40 y minus 30. G01 is your linear interpolation with a constant feed rate. So you can see similar way the coordinates that I have taken out one by one, you can see the same coordinates I have used on. And my last coordinate you can see, that is x40 and y40, that is my end point of the coordinate. You can see another green color arrow mark, it is there in the end point, that is x40 and y40. And after this my tool will rapidly move up to a height of 5.0 5 mm in plus side. Then again rapidly it will move on to the starting point, that is x minus 48 and y 40. This is a complete cycle, I can say one cycle. And next, how many times it will be repeated, according to that I have to give one more logic. And here same variable I will be using over here. Here has1 is equal to how much? It is has1 plus 0.2. 0.2 will be my incremental depth of cut after the first depth of cut. And the variable what I will be using over here, the logic I will give, that is if has1 is LE means less than or equal to 1 mm, then go to 1. I had told you earlier, I have mentioned n1, so here go to 1 means again it will go to the n1, and from that it will repeat the cycle. So unless until the depth is up to 1 mm, it will be continued, point 2, point 2, point 2, it will be cutting, and once it will attain the depth of 1 mm, then after that it will go to G00, Z5.0 safety height, M05 is spindle off, then M09 is coolant off, then G28, G91, Z0 is the homing for your Z axis, G28, G91, X0, Y0 is for homing of X axis and Y axis, and M30 is your end of program. So this is the complete cycle for facing program, one of the example I had given over here, and the same program will be running on the machine now. So now on the machine, how to write a program? First of all, we'll go to the edit mode in the mode selector switch, then we'll go to the program, then we'll press the directory button and we'll create a new program. Before that, we have to check which program number is not existing. So as you can see, 1, 2, 3, 4, 5, 6. Here what happens, 6 program was not there, so I inserted O006. Once the program is inserted, new program is made, then we'll start writing the program. The same program that I explained you in a slide, the same program we are going to write over here. In this manner, as you can see, how we are inputting the program to the machine. So we'll keep on writing the program unless until it gets completed. Once the program written is done, we'll check the graph whether the program that we have written is proper or not. So how to check the graph? We'll know it now. So first of all, to check the graph, we'll go to the auto continuous mode and keep the tool at a safety height. We'll not do the Z0, we'll keep the tool in a safety height. Then we'll go to the graph parameter and we'll erase the previous graph if anything it was there. Then what we'll do? We'll start the cycle, and as the machine will run, we can see how the coordinates we have written, according to that the machine movement is there or not. As you can see on the slide how I have shown you, the similar way the graph on the machine also we are getting in the same way. So you can see there is a movement in the x-axis particularly, and as well as in the y-axis also and z-axis also. Now the depth of cut is how much? 0.2. I told you initially we have given the depth of cut, that was 0.2, and feed rate is how much? 1120, that we have given the maximum. S is the spindle rate. I told you we have inserted 700 as the spindle rate. You can see that one. And T here, as there is no ATC, that is automatically tool changer. Here nothing is there. So for that purpose, what happens now? This particular graph is okay. Once the graph is okay, next we'll do the Z0 of the tool properly. Once the graph is okay, then we'll run the program, but before that the offsetting should be done. So we have done the offsetting already. If you want to see it properly, you can refer our previous videos in which we have discussed regarding the datum setting. And now we'll start the cycle in auto continuous mode, and you can see how the tool is coming down and it is cutting the material. As you can see over here how the program we have written, in similar way it is going to cut the material from the top surface of the job. So this is one of the zigzag facing cycle, I can say. So as we have given the depth was 1 mm, so till 1 mm it will be cutting in such manner. So this is the depth it has taken, that is 0.2. So you can see once it is completed, again now it will take another 0.2 depth. So this is 0.4 depth now in total, and now again 0.2 material is being cut. So now we are using the coolant. So always remember, coolant is to be used to increase the life of a tool and to achieve a good surface finish on the job. We should always use a coolant. And here it will repeat the cycle till the depth has been achieved to 1 mm. And you can see once the depth is completed, as per the program, the machine will stop, the spindle will stop, I can say, and the homing will be done. And you can see 1 mm of material has been removed from the surface of the job in a facing cycle. So here coolant is there, we'll clean it and we'll see how it looks like. As you can see over here, after the coolant and the chips are cleaned, these are the cutter marks we are getting it. So in this way the facing cycle is done. That was all regarding today's session on facing cycle. Hope you liked it, and in upcoming sessions we'll be having the discussions on contouring cycle. Till then, have a good time and don't miss our sessions on CNC programs. So thank you for today's session. Have a good day. Thank you all.